Welcome back to Summarize Science. Today, we're looking at a huge challenge for AI in medicine: trust. We have AIs that are incredibly accurate at predicting diseases, but they often work like mysterious black boxes, making it hard for doctors to trust their reasoning. On the other hand, some AIs can generate fluent, human-like explanations, but these can be statistically wrong, which is even more dangerous. This paper introduces a groundbreaking idea. What if high accuracy and trustworthy explanations aren't a trade-off? The researchers argue they are two sides of the same coin, born from a deep, direct understanding of the data, much like how a human expert learns from experience. To achieve this, they built a new system called the Reflective Cognitive Architecture, or RCA. Think of it as an AI that learns from its own experience. It uses a team of language models that work together in a clever way. First, every time it makes a wrong prediction, it doesn't just forget about it. It treats that error as an experience to learn from and updates its internal logic. Second, it has a built-in fact-checker that constantly compares its reasoning against the statistics of the entire patient dataset, ensuring its conclusions are grounded in real evidence. So, how did it perform? The researchers tested RCA against 22 other methods on 3 different disease prediction datasets. As you can see in these charts, the RCA models, represented by the triangles, consistently landed in the top right corner. This means they achieved the highest predictive accuracy while also producing the highest quality, easiest to understand explanations. But let's look at a concrete example to see why this is so important. Here, 2 AIs were given the same patient data to predict the risk of a catheter-related blood clot. The standard AI on the left incorrectly predicts the patient is at risk. It creates a plausible-sounding story, but crucially misunderstands a key lab value, calling a D-dimer of 0.84 elevated, when, for this specific dataset, it's not. Now look at RCA's reasoning on the right. It correctly predicts no clot because it learned the actual risk threshold from the data, stating the D-dimer level is below the threshold of 1.5. It also provides a balanced view, acknowledging the risk factors but explaining why they aren't sufficient in this case. This is the difference between an AI that sounds smart and an AI that is genuinely intelligent and grounded in evidence. So to recap, this new architecture forces an AI to build a deep, first-hand understanding of clinical data. It achieves this by learning from its mistakes and constantly grounding its logic in statistical reality. The result is not just a more accurate prediction, but a clear, logical, and evidence-based explanation that a doctor can actually trust. This research represents a major step toward creating AI systems that can work as reliable and transparent partners for doctors in high-stakes clinical settings. What do you think about an AI that learns from its own experience? Let us know in the comments below. Thanks for watching Summarize Science.